So hello everyone, this is the video about answering some questions of this paper multiple choices of Cambridge IGCSE. This is the February-March 2022 version, and all those 40 questions must be answered within 45 minutes. So let's jump directly into questions. In this video we're going to talk about the first 10 questions, and the others, the remaining questions, would be answered in other occasion. We have the first question here is a student investigates a pendulum. He measures the time of the pendulum to complete 20 oscillations. He repeats the experiments 3 more times. The readings are shown in this table. The question is to know what is the average period of the pendulum. That means the period of one oscillation. So, knowing that all these measurements are done for 20 oscillations, this is in second. That means the first step is to calculate the average time of these 20 oscillations. After that, we're going to look for the time of the period of this pendulum. So the average is known as the sum of the total period here divided by the number of tries. We have 4 tries here, or 4 experiments. What will we do is 17.6 plus 19.8 plus 17.6 plus 18.6 divided by 4. So this is the average of the 20 oscillations. Let's do it quickly with calculator. 17.6 plus 19.8 plus 17.6 plus 18.6 divided by 4. This is giving 18.4. So the period of the pendulum, that must be divided by 20. We're going to do it. This is given 0.92 seconds. Means the B is the answer for our question here. The second one here is the diagram shows the speed time graph for a moving object. This is the speed against time. As we see, it's a straight line graph. Which statement describes the motion of the object here? So for A, here we are, the speed of the object is increasing with the constant acceleration. This is actually the answer, because it's showing the increasing of the speed as the time goes, and the constant acceleration because of what? Because the acceleration could be calculated from this graph by calculating the slot here. The rise divided by the runs will give the acceleration and must be a constant, as this one is a straight line. So here the acceleration is not a constant, and for sure here the speed is not decreasing. The next question here is about this situation. We have a tennis ball falls from the upstairs window of the house, or of a house, here to the ground. What can be said about the acceleration of the ball if air resistance is ignored? There is no air resistance. So, is the acceleration depends on the density of the ball? It depends on the mass of the ball. It increases as the ball falls. It stays the same as the ball falls. The Newton's second law says that the only force applied on the ball, or on the tennis ball, is the weight, which is the m times g, mass times gravitational field, equals to what? Equals to mass times acceleration. Getting rid of this mass here, that means the A must be G, and the G in our case here is a certain constant, which is for sure almost 10 meter per second square. So in our case here, the acceleration is constant. It stays the same as the tennis ball falls to the ground. The same, or sorry, the mass of a full bottle of cooking oil is 1.30 kilograms. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.90 kilograms. This is the situation here. For bottle is 1.30, half filled bottle is 90 or 0.90 kilograms. The question is to look for the mass of the empty bottle. So here we have two unknown things, the mass of the oil and the mass of the empty bottle. Let's define this. Let's represent the X as mass of bottle and the Y as mass of oil. The first statement says that if we add the mass of the bottle to the mass of the oil, it's giving 1.30 kilograms. And the second statement says if we add the mass of the bottle plus the half quantity of the mass of the oil, this is giving 0.90 kilograms. So this is actually a mathematical system that we have to resolve. Two equations with two unknown quantities. Let's name this one 1 and this one as 2. If we subtract the 2 from the 1, that's gonna give x plus y minus x plus y divided by 2. That will give 1.30 minus 0.90. Developing this, we're going to find x minus x is 0, y minus y by 2 is y by 2, and 1.30 minus this 0.90, this is 0.40, this is 40, which means the y would be 2 times 0.40, it's 0.80. So the y was the mass of the oil. Let's come back here to the first equation here to find the x, which is the mass of the bottle. That's what we're looking for. X plus y equal 1.30, that means x would be 1.30 minus the y, means 1.30 minus 0.80. The x finally would be equal to, this is 20 and 30.50 kilograms. Is there any proposition of this value, 0.50 kilograms? Yes, this is the answer for this question. So the next one is here. A student carries out an experiment to find the density of a rock. The situation here, we have a scale with a measuring cylinder filled with a certain liquid, and we're going to put inside a rock. Which two quantities does the students need to make to determine the density of the rock? So here, for A, increase in mass, this is correct. Increase in mass, that means we're gonna choose between the A and the C. Is it the first or the third one? Increase in volume, increase in depth of liquid. It's the first one actually. The volume would be increased. It was here and it's gonna be at this level. The difference would be the increase of the of the volume. So the A is the answer for our question here. Okay, so the next question is, a spring is suspended from a stand, loads are added, and the extensions of the spring are measured by this rule. So this is the stand. We're going to suspend the spring, and the free end of the spring we're going to suspend loads, and each time we're going to measure the extension. So the question is to choose between loose graphs. Which one shows the result of plotting extension against load? There is a law says the force applied by a spring is directly related to x extension, to this x, which is extension. It's denoted as x or e sometimes. So the k is just a constant. That means the f is directly linked to the extension here. As we add a load here, the load has a mass, means it's applying a certain weight. So at the equilibrium, this force applied by the spring would be equal to the weight here. So the weight here is representing the load, and this kx is representing the force applied by the spring. As we see here, the load is also directly linked to the extension. That means if we don't have a weight, there wouldn't be any extension. And as we increase the load, the extension is proportionally increases. So we have two things here. No load means no extension, and the load is proportionally linked to the extension. As this one increases, this one will be increasing also. So it's not this one because this extension is decreasing with the load. This extension stays the same as we add a load. That means it's not the right one. This one shows there is already a certain extension even we didn't add any load. So the remaining one is the D choice, or the D option. This is the one that we're going to choose as a correct answer. For the seventh question here, we have, which are examples of friction from these three: tension in a spring, air resistance, weight. The weight is a distance force actually. The earth is applying a certain attraction force, what we call the weight, and there is no contact between the two. The tension in a spring. The tension in a spring, if we have a spring, it's applying an opposite force to the weight for this example here, and there is no actually friction because there is no opposite movements between to the two, or one to each other, so we can not choose neither this one nor this one. The air resistance. The resistance of the air is actually an example of friction, because once we study an object that's moving in the air, the particles of the air are actually applying an opposite force against the direction of the movement. So the air is certainly an example of friction. The answer for this one is 2 only, C. The diagram shows a nut being turned with a spanner by applying a force F to the spanner. We're applying this force vertically toward down to just turn this nut. Which equation gives the moments of the force F about the center of the knot here, this point? The moment is known as the force times the distance. The force is already known. The distance is the smallest distance between the center of, or the axis of rotation of this system, and the straight line supporting the force. The straight line supporting the force, that means we have to do a certain projection here. That's the distance that must be measured so we can measure or calculate this moment. This distance is already denoted as x for us here, so I have the F and I have the D, which is x. The moment for F is that F times x. So the answer for me is Fx. It's not Fy, it's not F over x, it's not F over y. A child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? So we have the situation here. The ground and the car has been pushed and released at a certain moment. So this toy car must be stopped at a certain distance because of what? Because of the frictions between the car and the ground. As the car is moving, it's animated with a certain velocity or a certain speed, which means it's storing what we call a kinetic energy. We already said there is friction which are responsible for the slowing down of this car. So when we talk about friction, there must be generation of what we call a thermal energy, heat. With that being said, we can say that the kinetic energy is transferred to the thermal energy. The option here is from kinetic to thermal. Energy resources are used to produce electricity. Which resource is non-renewable? That means the one that we can use over and over. The hydroelectric production of electricity uses the power of water. So the water could be used many times. That means it's a renewable resource. The waves in the ocean, in the seas, are also renewable. The wind could be used over and over. But the nuclear fission, as it's used, it couldn't be used again. So it's a fossil resource. Actually, it's not renewable. So the B is the answer for this question 10. We have more question 30 other question that must be answered. So just to not make this video longer, we're going to stop here and answer the remaining ones in other videos. Just don't forget to just put your comments and like this video so we can go forward.